Okay, so as in the last video, we have discussed about quantum numbers, just an introduction to the quantum numbers. Alright, in today's video, we're gonna deep dive into these quantum numbers. What are these, what they are used for, and why are these made. Alright, we're gonna discuss each and everything in very detail. Initially, we discussed that no one gave the wave equation rather than Schrodinger. He gave a wave equation in which he used a wave function xi, right? So his wave equation was d2 xi upon dx square plus d2 xi upon dy square plus d2 xi upon dz square plus 8 pi square m upon h square into e minus v is equal to 0, where xi was the wave function and E was the total energy, V was the potential energy, and M was the mass, pi was the constant, and H was the Planck's constant as well, whose value is 3.634 into 10 to the power minus 34 joule second. Alright, this was a Schrodinger waves equation, or you can say Mater's wave equation. We were discussing about the quantum mechanical model. With this equation, with this Schrodinger wave equation, or you can say Mater equation, we got three quantum numbers. Three quantum numbers were principal quantum number, which was denoted with N, azimuthal quantum number, which was denoted with L, magnetic quantum number, which was denoted with M, and spin quantum number, which was denoted with S. Alright, now today we're gonna see what are they used for. These quantum number, the three quantum number will gonna tell us about the size of the orbital, or you can say size of the shell, and they're gonna tell us the shape. With that, they'll gonna inform us about the orientations as well, right? So fourth quantum number will gonna tell us the spinning of the electron. This equation is basically made for finding electron where electron would be present. So you can say this is the probability wave equation as well, probability of finding electron wave equation as well, because with this equation we got to know, or there is a probability of electron here, right? As you can see, this electron is here. So with this wave equation I can easily find, or I can have a probability of electron finding here, right? So this gonna tell us the probability of finding an electron in the shells, right? So these four quantum numbers, initially let me write here quantum numbers. So wait, quantum, wait, I need to start from here. Quantum numbers. With this equation we just got three quantum numbers: principal, azimuthal, magnetic, and spin quantum number we didn't get from this equation. Alright, and but we have four quantum numbers. We have four quantum numbers. Alright, so yeah, let me make it here. There would be one, here would be second one, here would be third one, and here would be last one. Alright, so initially we have principal quantum number, principal quantum number, which is of course denoted with N. So here N. Alright, then we have azimuthal quantum number, azimuthal quantum number, quantum number, which is denoted with L. Then we have magnetic quantum number, magnetic magnetic quantum number which is denoted with letter M. Alright. And last but not the least, which is spin quantum number, which we have not got with the help of this equation. However, we have 4 quantum numbers which tells us about the spinning of the electron. Either that would be moving anti-clockwise or clockwise. Alright, so spin quantum number which revolves or which is represented with letter S. Alright, so I have written here 4 quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. Now, what the principal quantum number is used for? Principal quantum number is used for to tell about, what, the size, how big it would be. Alright, so it tells us about the size, right? Size, which means it tells us about the shells. Alright, we know that initially we have shells. When you'll go inside the shells, you'll gonna get into the subshells. After subshells, you'll gonna get into the orbitals. Alright, so you can take principal quantum number as they are giving information about the shells, since it is telling us about the size, and size means it is telling us how big it would be, means it would be telling us about the shells, in which shell the electron would be present. Alright, so which means it is informing us about what? Which means gives information about shells, and we know that what shells we have, what they are represented with. They are represented with K, L, M, N, because there are fixed energy levels, as it was stated by Neil Bohr. Alright, so there are K, L, M, N. Alright, K, L, M, N. K, L, M, N, and so on. Alright, and so on. So what principal quantum number tell us about? It tells us about the size, which means it tells us about the shells, K, L, M, N. Alright, then we have azimuthal quantum number, which will gonna tell us about the shape. They're gonna tell us about the shape. Alright, they're gonna tell us about the shape, which means they're going to give us information about the subshells. Gives information about subshells. Alright, which means SPDF. Alright, we know that we have SPDF. They are the subshells. They are what? They are subshells. So SPDF subshells. And shape, we have basically we have spherical, dumbbell, double dumbbell, and 4 folds or 8 folds. Alright, so we have 4 shapes as well, that I should write with blue one. 4 shapes we have: spherical, dumbbell. In next video we're gonna discuss about the shapes in very detail. Dumbbell, D dumbbell means double dumbbell, and 8 folds. right? So there we're gonna discuss about the shapes as well. Then we have magnetic quantum number. This is just the basic introduction to all these four quantum numbers. Just a basic introduction. In next video, we're gonna deep dive into these. We're gonna check the formulas as well. How many subshells would be there in the shell? How many electrons would be there in the shell? Or how many electrons would be there in a one orbital? Or how many electrons would be there in the subshell? We have a lot of formulas, and we're gonna learn those in the next video. But here we're just gonna discuss the basic introduction. Alright. So we have now the magnetic quantum number will gonna tell us about what? They will gonna tell us about the orientations. 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 Which means they're gonna tell us about the orbitals. What they're gonna tell us? Gives information about orbitals. Orbitals, right? Means in S we have only one orbital. In S means this is the S1. Here we have only one orbital, right? In P we have three orbitals. We're gonna check it out how we have three orbitals, how then we have five orbitals in D, how we have seven orbitals in F. We're gonna check everything out. Alright, so let me write here D as well. In D we have five orbitals. So 1, 2, 3, 4, 5. Alright, we're gonna check everything out. So last but not the least is spin quantum number, which will gonna tell us about the spinning of an electron. Spinning of an electron. How it will gonna revolve. Alright. This information we'll gonna get from the spin quantum number. Gives information about moving the direction of spin. That would be very nice word here, right? Direction of spinning. In which direction it would be spinning. Alright. So spin quantum number will gonna tell us about the spinning of an electron. For example, if I have an orbital P, I have a subshell P. Alright, we know that in P subshell we have three orientations, three orbitals. Now how electrons will be moving in these? One orbital will gonna have two electrons. Alright, but according to Hund's rule we need to fill all the electron with clockwise movement first, or you can fill them all with the anti-clockwise movement first. Then you need to start filling the electron again with anti-clockwise, right? So this would be the spinning of the electron. We're gonna discuss each and everything in very detail in the next video. So this was all for today.